All right, so number 13 at the top of the next page says sketch the graph and label key points. Hopefully I can look at this and recognize vertex form of a quadratic and know that it's going to open up, shifted to the left by 2 and down by 5. 2 was positive, so it opened up. So we're going to have a stretch that we'll have to deal with. I'm going to do this completely transformationally, and then later I'm going to plug in some points to prove that it worked. So, because you can always make a table of values, guys. Don't forget that's still a thing. I'm just so bad at arithmetic that it would be embarrassing. So I'm going to find where x plus 2 equals 0 is at x equals -2, and then down by 5. Good thing it opens up or I'd fall right off my graph. That's my vertex. Now normally, my normal parabola would go through the point 1, 1, and 1, -1, right, from the vertex. But because it's stretched vertically, vertical stretch by 2, when I go over 1, I'm going to go up 2. Now I'm also going to go over 2, and instead of up 4, 1, 2, 3, 4, I'm going to go, which is 2 squared, right? I'm going to go up 8. 1, 2, 3, 4 again. So this is my next point. And then the axis of symmetry should inform me that this point is going to be here, and this point is going to be here. So there's my y-intercept of 3, which doesn't look like it should be there, but this isn't standard form. So when x is 0, I get 2 squared, which is 4, times 2 is 8, minus 5 is in fact 3. So I was expecting a y-intercept of 3. And that's as many points as I can possibly graph, and it's just this very steep parabola that looks like this. Now if I'm going to make an xy table, thinking about transformations will tell me a little bit more about where to start. I don't want to start by plugging in x is 5 and working my way to the left. I would not get anywhere useful. So instead, I'm going to start with x is 0 and then do -1 and -2 and -3. Those choices are based on my analysis of the transformations, expecting to find key points in that area of the graph. So I'm not just going to randomly put in -3, -2, -1, 0, 1, 2, 3, or start with 0. I don't know. I'm choosing that deliberately. So when I plug in 0, I am plugging it into 2 times x plus 2 squared minus 5. So when x is 0, I have 2 times 2 squared minus 5, which is 8 minus 5, which is 3. So the point 0, 3 is on my graph. Now when I plug in -1, I have 2 times -1 plus 2. -1 plus 2 is 1 squared minus 5. That is 2 times 1 is 2 minus 5 is 2 minus 5. -3. There we go. Oh good, that point is there. So I have the point -1, -3. -2 now, 2 times x, -2 plus 2 is 0 squared, makes this whole piece go away, and I get -5. So -2, -5, that was my vertex. When I get 0 in the parentheses, that is a clue that this is my vertex. But I'm also going to get another clue when this happens. So 2 times -3 plus 2 is -1, and -1 squared is +1. So 2 minus 5 is -3. So now I have that mirrored point of -3, -3. And I can see that I've started to come back up again. These bounced off of my vertex that was right here. That is my lowest point. Now you won't always find your lowest point on a table because it won't always be at an integer position. But when it's in vertex form and you can see that your transformations, your shifts are all integers, then tables are great because you're going to find it on that integer position. Okay, sketch and graph, label key points. So Labeling my points means on the graph. -2, -5, and 0, 3. Now I can't label my y-intercepts. Oof. Or I'm sorry, those are my x-intercepts. I can't label my x-intercepts because they're somewhere in space. I know approximately where they are, but I would have to do a lot more work to solve those. I'd probably have to put it into standard form and then use the quadratic formula because they look like they're likely to be irrational solutions. I don't want to do that work, so I'm not going to label those points because they're not obvious on the graph. You might be like, well, why don't you just plug in y = 0 and solve for x? Well, that's the whole point. I guess I could. Oh, I could because vertex form. Oh man, this is easier than I thought. I don't have to put it in standard form or use a quadratic formula. It's in vertex form. When I plug in y = 0, I can isolate my squared. I'm going to add 5. I can solve it like it's an absolute value equation, right? Try and isolate the absolute value piece and then split it into the 2 when I square root it. So this becomes 5/2 equals x + 2 squared. When I take the square root, now I'm actually going to have to take the square root and realize it's plus or minus. So I'm going to have plus or minus the square root of 5/2, which is some weird ugly number, equals x + 2. I'm going to subtract 2, and I have -2 plus or minus the square root of 5/2, which is what I would have gotten, sorry, that's my x, what I would have gotten from the quadratic equation. But I can get it when it's in vertex form by just solving like I do a vertex form equation or an absolute value. The parallels between the solution strategies for quadratic and for absolute value cannot be overstated. They're both V-ish shapes. They both have a max or a min. They're super similar, including their solution strategies. Isolate the parent operation, and then when you undo it, it splits into 2 equations, one with a plus and one with a minus. So these can be labeled. This is probably -2 plus √5/√2, comma 0, and this is -2 minus √5/√2, comma 0. There you go. So I labeled all my key points. Now, since vertex form is so helpful, let's go ahead and put our function into it. This is going to require a process called completing the square.
Oh, that's our least favorite activity right there.
But it's called that for a reason, because the whole goal is to find the missing piece of the square. So first what I'm going to do is push my constant over to the other side to get it out of the way. And now I have x squared plus 14x, and I'm going to create my skeleton of I don't know what goes there. But whatever I add, I also need to subtract so that I don't change the value of that side of the equation. Or you can think that you add it to this side. I forget what delta math does. But what goes there is going to be whatever goes here. So this is not rocket science. I put my x squared here. I need my 14 x's to be evenly distributed. So I get 7 x's here and 7 x's here. So I have x plus 7 and x plus 7. Now it's a square. So what goes here? 49. So I'm going to add 49 and subtract 49. And that will allow me to rewrite what's in parentheses as x plus 7 squared, because it is a square with a side length of x plus 7 and a side length of x plus 7, but then minus 49 because that's outside the parentheses. But everything in here was in the box. It now can be replaced by that perfect square expression. So now I'm going to subtract my 38 back. Minus 38, I get x plus 7 squared minus 70, holy moly, 50, and 38 is 88, 87. I'm going to go with maybe that's negative 87. You can correct me later. But now it's in vertex form, and I didn't have an A to fuss with, so my vertex is -7, -87. Because this was a shift to the left by 7. The value -7 is when this equals 0. That is the x value that makes this equal 0, which will get me my most minimum point. My y-intercept, now, the y-intercept is actually easier to find from here. It's -38. Because standard form, that's the one thing it's good for. The axis of symmetry then is whatever my x coordinate is, whatever my horizontal shift is, x equals -7. So all of this was very doable when you draw the square and understand how that area model works. Sketch each function and identify the solutions to the system of equations, if any. So this is a nonlinear system of equations, 2 equations, but this one's a quadratic opening up, and this one is a line with a negative slope. So it might be like that, or it might be like that. I don't know, maybe it's tangent, I don't know. So there's either 0, 1, or 2 solutions to this system of equations. So I'm going to need to plot it to get a sense of which one it is. So 2x squared minus 3, that's not, actually it is in vertex form. So I have no horizontal shift and I go down by 3. So basically you could also think of it as plugging in values. When x is 0, y is -3. That's my y-intercept. It might be my vertex, it might not be. Since I think of it in transformation form, I know it is, but I can test values to the left and right. So -1, 2 times -1 squared is a +1, so 2 minus 3 is -1. That's up from there. +1, well, that's going to be 2 minus 3 as well, which is also -1. So now I can see that bouncing action that's happening here. So my quadratic went over 1 and up 2. That was the vertical stretch that we've talked about before, which means if I go over 2, I'd have to go up 8, because it's 2 squared times 2. 1, 2, 3, 4, 5, 6, 7, 8. So there's my point there, and there's my point there, and here's my parabola. Okay, all of that's unnecessary. All right, so now the question is, where's my line? This could be written as y equals -x plus 3 if you really want to see it in slope-intercept form. All I have to do is bring that negative with the x because it is being applied to the x. Think of it as 3 plus -x if you want to. Either way, my intercept is 3. I'm going to go ahead and draw this in red. Intercept is +3, 1, 2, 3. So it looks like I will have 2 solutions since I'm trapped inside. And then my slope is -1, down 1, over 1, down 1, over 1, down 1, over 1. Over 1, up 1, left 1, up 1. Oh, I found one of my points through a careful graphing, but the other one I don't know. So I can find this solution because it happens to be on one of the points that I plotted. -2. -2 makes 4 plus 3 is 7. So I'm expecting 7 here, but I'm going to carefully plug it in. 2 times -2 squared is 4, minus 3, 8 minus 3 is 5. That's not 7.
No, the Muji ones are really cute, but you have to.
Oh, 2 plus 3. I don't know why I have 4. I was already thinking ahead of squaring. Sorry. Negative and -2 is +2 plus 3. Okay. So I got 5. -2. This is why I don't do numbers, guys. I'm sorry. But -2, 5 is one of my solutions. Now the solution set is points. -2, 5 are the xy pair that will make both equations true. When there's 2 variables, my solution set gives both variables because they are the points where they cross. So I need both variables. So the system of equations. Looking for the other solution here. Well, that one's a little tricky graphically. I know that it's something like 1 point something, right? And up 1 point something. But I don't know if they're the same something or not the same something. I really don't know what's going on there. So I'm going to have to solve it the other way. The other way is to say, well, if both of these are equal to y, then both of these are equal to each other. And I need to solve this equation, right? If that's y, then I can replace y with 3 minus x. Set the two equal to each other. So to solve a quadratic, I need to get everything over to one side. I'm going to get 2x squared plus x. And then there's a negative 3, and I'm going to subtract 3 more, so minus 6 equals 0. So now I need to find the factored form. I'm going to move it over here because this is going to be in my way. I need to factor 2x squared plus x minus 6. Now the thing is, I expect it to be a fraction of some kind. If it works, that's great. If it doesn't, then I revert to the quadratic formula. So one of these is 2x, one of these is x, this is negative 6. I need this to equal 1x, positive 1x. So one of these is minus, one of these is plus. This one's going to be multiplied by 2 because the width of this is 2x, right? So I don't know what this is. This could be 1 and 6 or 2 and 3. 4 and 3 are 1 apart. I like that. 4, because one of these is going to be multiplied by 2. 6 and 2 are too far apart, but 4 and 3 are the right distance. So I want to put a 2 here to make 4, and then a 3 here. Now I want this to be the positive so that I land on positive, and I'm going to subtract 3x, so this will be the negative. So my factored form is x plus 2 times 2x minus 3 equals 0. I need to know where x plus 2 is 0. And that's at negative 2. I already found that solution. But I also need to find where 2x minus 3 equals 0, or 2x equals 3, or x equals 3 halves, 1.5. My solution is 1.5. Now when I plug that in, 3 minus 1.5 is 1.5, so there is some amount of symmetry to that. And my final solution set is 1.5, 1.5, or 3 halves, 3 halves. This is my solution set.
I have no stickers. I need to put stickers on
It's this point and this point. As predicted, when I did my quick sketch, I have 2 points that are solutions. Great. I'll make another video for the next page.
Like it's a combo journal planner.